Imagine you're a 16-year-old in your bedroom. You download a single file from a forum, hit enter, and suddenly, a multi-million-dollar company's website goes dark. You didn't write the code. You don't even know how it works. But you just took down a giant. Welcome to the world of the script kiddie. In the cybersecurity world, it's a slur, an insult, but in 2026, these amateurs are causing billions in damages. Today, we're breaking down what a script kiddie actually is, the forbidden tools they use, and why most of them eventually get caught by the very scripts they run. A script kiddie, or skid, is someone who lacks the technical skill to write their own exploits. Instead, they use pre-made software, often called scripts, created by professional hackers. Think of it like this: an elite hacker is an engineer who can build a car from scratch. A script kiddie is someone who found the keys to a stolen Ferrari. They can drive it fast, they can crash it, but they have no idea how the engine works. So, what's in a skid's toolkit in 2026? It usually starts with Kali Linux. It's the ultimate Swiss Army knife of hacking, but for a script kiddie, it's mostly just for show. Here are the top 3 tools they lean on. Low-EQ, low-orbit ion cannon, the classic. It's a point-and-click DDoS tool. You put in an IP, hit I'm a chargin' ma laser, and flood a server with traffic. It's loud, it's messy, and it's the easiest way to get your ISP to call the police. Metasploit, a professional tool, but skids use it for autopwn. They find a vulnerability online, copy the module, and pray it works. Social engineering toolkits, set. Since they can't code a backdoor, they just trick you. They'll send a fake login page that looks exactly like Instagram or Facebook. Here's the plot twist: in 2026, there is no honor among thieves. Professional hackers often release free hacking tools on the dark web that are actually Trojans. A script kiddie thinks they are downloading a tool to hack their school, but as soon as they run it, they become the victim. The free tool installs a backdoor on their PC, steals their passwords, and turns their computer into a botnet node. Plus, because they don't know how to hide their IP or use advanced OPSEC, they leave a digital trail a mile long. Law enforcement loves script kiddies. They're the easiest ones to catch. Everyone starts somewhere. If you're curious about code, don't be a skid, be a white hat. Instead of breaking things you don't understand, learn the why. Start with Python, learn how a TCP handshake works, and practice on sites like TryHackMe or Hack the Box. In 2026, the world doesn't need more people who can hit run. We need people who can build the shields. If you enjoyed this deep dive, hit that subscribe button for daily cybersecurity updates. ###***1. The Control Center imports ***. At the top, we have our 3 main modules. ****time*** is the most important here. It's used to create artificial delays, which builds the psychological tension. ****random** is used to cycle through a list of file names so the scan doesn't look the same every time you run it. ****2. The visual framework. Inside the ****fake_virus function, we use string multiplication, equals, *50, to create a clean, professional-looking UI border in the terminal. In cybersecurity, presentation is everything when you're trying to fool a user. ****3. The randomized file scan ***. The script defines a list called *files* containing high-stakes names like *system32.dll* and *boot.ini*. We then use a * for loop * that runs 10 times. Inside that loop, *random choice files grabs a random name from our list, and *time sleep 0.3 pauses the script for 300 milliseconds. This mimics the behavior of an actual antivirus, or a malicious wiper, searching the drive. ###*4. The dynamic progress bar. This is the most visual part of the script. We use a asterisk range function asterisk that counts from 0 to 100 in increments of 10. The code #I10 calculates how many filled blocks to show. The code ***10I10 calculates the empty space. As the loop progresses, the bar fills up across the screen, creating a sense of urgency. ###*5. The psychological countdown. Finally, we have a asterisk reverse range asterisk. *5 0 -1 This counts backward from 5. By using time sleep 0.5 we create a rhythmic ticking clock effect. It's the ultimate social engineering trick, making the victim believe they have only seconds to react before their system is gone. This code is a perfect example of false flag programming. It doesn't actually touch the registry, it doesn't delete files, and it doesn't even need admin privileges. It's 100% print statements and sleep timers designed to trigger a panic response. This script is a hybrid attack simulation. It combines Python for environment handling with JavaScript, JS, and HTML, CSS to create a visual prank, specifically designed for interactive environments like Google Colab or Jupyter Notebooks. ###*1. The bridge, Python to browser, *Ipython****. The most important part of this code is the *import Ipython statement. Standard Python scripts can usually only print text. However, by using *Ipython display HTML we can inject live web code directly into the user's browser. This allows the hacker to control the visual UI of the victim's workspace. ###*2. The virtual container, HTML, CSS, The *HTML code variable contains a less than div greater than styled with position, relative This acts as a sandboxed environment. ****overflow, hidden ****. This ensures that any pop-ups generated by the script stay inside the small box, preventing them from breaking the rest of the web page. ****background color. Number 1E1E1E ****. Using dark mode, styling mimics the look of a real developer terminal or a command and control C2 center. ###*3. The recursive pop-up engine, JavaScript The logic inside the less than script greater than tag is what makes the prank annoying and effective. ****spawn pop-up This function is recursive. It calls itself every 800 milliseconds using set timeout, spawn pop-up 800 dynamic positioning It uses math random multiplied by the container's width and height. This ensures that warning boxes appear in random locations, making it harder for the user to close them quickly. ###*4. The mouse avoidance logic social engineering The real prank is in the on mouse over event listener JavaScript btn on mouse over equals function btn style margin top equals math random 40 plus px btn inner text equals too slow In cybersecurity, this is a simulation of *GUI redressing. When the user tries to click close, the button physically moves away from their cursor and changes its text. This creates a sense of losing control over the computer. A common tactic used in *scareware to panic the victim into calling a fake support number. ###*5. The simulation cap. The script includes a kill switch, if count greater than equals 15, This prevents the browser from crashing due to an infinite loop of memory usage. Once 15 alerts are generated, the simulation ends with a standard JS alert box. Question of the day. What's the first hacking tool you ever heard of? Let me know in the comments. Stay safe, stay ethical. I'm your channel name, and I'll see you in the next one.